right, guys, so in this do now, we're given a triangle here. It says, using the triangle, evaluate the six trig functions for the angle. Uh, Angle A is we're going to label as theta. Angle B we're going to label as alpha, and then angle C here is a right angle. All right, so I'm just going to put the theta and alpha in the diagram. All right, so from here we're going to do the six trig functions. So sine of theta. So remember from SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, so sine of theta, opposite over hypotenuse, is going to be little a over c. Cosine of theta, so it's adjacent over hypotenuse, so it's going to be b over c. Tan of theta is opposite over adjacent, so it's going to be a over b. Cosecant of theta, so cosecant is the reciprocal of sine, so instead of opposite over hypotenuse, it's going to be the hypotenuse over the opposite, so it'll be c over a. Secant is a reciprocal of cosine, so it'll be c over b. And then cotan of theta is going to be adjacent over opposite, so it'll be b over a. Cosine of alpha. So if we're looking from essentially angle B here, cosine would be the adjacent over the hypotenuse, so it'll be a over c. Sine of alpha will be b over c, it's opposite over hypotenuse. Now cotan, instead of it being opposite over adjacent, will be adjacent over opposite, so it'll be a over b. Secant of alpha will be the reciprocal of cosine, so it'll be c over a. Cosecant of alpha will be the reciprocal of sine, so it'll be c over b. And then tan of alpha will be the reciprocal of cotan, will be b over a. All right. So now, if you notice, if we kind of look across at, and we read left to right each way, sine of theta, cos of alpha, they're the same value. Cos of theta, sine of alpha. Tan of theta, cotan of alpha. And then if we were to reverse, cosecant of theta is the same as secant of alpha. Secant of theta is the same as cosecant of alpha. Cotan of theta is the same as tan of alpha. So this leads us to one of the fundamental identities, which is talking about cofunctions. So what we saw in the do now, the angles in the triangle in the do now, theta and alpha, are complementary. And that's actually the root word for cofunctions. It comes from the fact that the angles are complementary to one another, or you can say that they're complementary if you want to kind of mispronounce it and force it, so that way we can see like why they're called cofunctions. And I also want you guys to notice the pairs of angles that are equal. All right, so we saw that with sine and cosine, tan and cotan, cosecant and secant. So those are the cofunctions with one another. Sine and cosine are cofunctions, tan and cotan are cofunctions, and cosecant and secant are cofunctions with one another. All right. So I'll write it there. For example, that sine of theta was equal to cosine of alpha. And we actually already saw this too in the unit circle. So I'll just write a quick recall. So for example, this is only one, but we saw that the sine of 60 degrees was the same as the cosine value at 30 degrees. And we can flip it. If you were to change it to sine of 30, that would be the same as your cosine value of 60 as well. Okay. And this is a common SAT problem, these cofunctions. Okay. I'll highlight that there. Cofunctions are definitely, you'll see them kind of appear a few times within the SAT. I'll just move this here so we have some more room. So our cofunction identities state that sine of 90 minus theta is equal to cos of theta. All right. And it makes sense, right? Because um, if we think about the angle measures inside of a right triangle, uh, if we know one angle is theta, then the other angle has to be just the difference between 90 and the other angle. Okay, so that's why these cofunction identities are true. Sine of 90 minus theta is the same as cos of theta. Cosine of 90 minus theta is the same as sine, and then the same will be true for the other cofunctions, tan and cotan, secant and cosecant. And I just want to also add an additional note, because this is in terms of degrees, but we can also add a note that we can also use pi over 2 instead of 90. So it's in terms of radians. Let me erase that there. So it's in terms of radians, okay? So you'll see these cofunction identities being used in the SATs, especially I think it's more in terms of degrees than it is in terms of radians. But just so you know that you can also just replace all these 90s with pi over 2 minus theta, and it'll still be true.